Good evening. I'm Spot On Weather meteorologist Matthew Euler. Welcome to my latest video. I know it's been a little bit of time, since my last video, so I was hoping to cut this a little bit earlier. But we just got out of the holiday weekend. I hope everybody out there watching this video had a great Thanksgiving holiday with your friends and family. And so now it's time to roll up our sleeves and get back into some of the videos here on the Spot On Weather YouTube channel. And I took a look at memorable East Coast winter storms in a previous video. Now in this video tonight, I want to go ahead and bring things in a little bit more closer to the Hampton Roads, Virginia cities. So this video is going to focus in on memorable Hampton Roads winter storms. This graphic, or rather photo, this photo is from the late December 2010 snowstorm. This was quite a storm system. Quite a winter storm for the Hampton Roads cities. Let me go ahead and get my laser out here. You can see the snow-covered streets at this point in late December 2010. And it was just a really interesting storm. And it's one of the many storms I'm going to talk about here this evening. But before I get to the actual storms themselves, we need to look at the overview here and what I'm going to cover in tonight's presentation. The first main point I'm going to go over is winter weather overview for Hampton Roads, Virginia. We'll take a look at, in general, what type of conditions are necessary, winter weather criteria for Hampton Roads, Virginia cities, and then I will conclude the video with memorable Hampton Roads snowstorms. Now, I did not quite get in deep enough to look at the associated teleconnections during those events, but it's definitely something of interest that I intend to take a look at a later time, just not in this particular video. All right, so let's first take a look at the winter weather overview. What causes winter weather for Hampton Roads, Virginia cities? Now, one of the unique properties of Hampton Roads geographically and where it's located is the vicinity of the Hampton Roads cities to the nearby Atlantic Ocean. We have specific criteria that must be met for snowstorms to occur across the area in the winter season. Now, if we look at normal conditions east of the Mississippi River in the wintertime, you would note that normally the 540 decameter thickness line is used for the rain-snow predictions east of the Mississippi. However, due to the modifying effect of the nearby ocean water on Hampton Roads cities, this value must be lower for snow to fall. Now, for winter weather lovers, I will say this, me being a winter weather lover, and I know many of you who live in the Hampton Roads cities are also winter weather lovers. One of the biggest things about the nearby ocean, the Atlantic Ocean, it can be both a blessing as well as a curse. Now, what do I mean by a blessing? What I mean by a blessing is major winter storms and getting that moist conveyor belt, adding the copious amounts of moisture off the nearby Atlantic Ocean can really enhance snowfall totals, resulting in heavier snowstorms for the Hampton Roads cities. But at the same time, the curse aspect is how the wind, if it's blowing over any kind of trajectory over that water, it can actually result in modifying the overlying air mass, and that will result in an elevated warm layer, or when I say elevated warm layer, I mean an area of temperatures that are above freezing point, 32 degrees Fahrenheit or higher, aloft above the surface. And as that elevated warm layer increases in its depth or its thickness, that's going to result in much heartbreak for many winter snow lovers, for example, winter storm snow lovers. I've seen a lot of storm systems go from a snow initially to a changeover to rain, a cold rain based on any kind of wind component off the nearby Atlantic Ocean. And what happens over time is the elevated warm layer, that area above 32 degrees Fahrenheit, above the freezing point, it gets thicker or deeper in depth in the atmosphere, and things are initially cold enough aloft at the cloud level, the base of the cloud, where things initially start off as snow, but eventually those snowflakes melt into the elevated warm layer, and by the time it gets to the surface, we just have a cold, nasty rain. Now, the rain-snow line. This is just from personal observation. The rain-snow line generally sets up across Hampton Roads cities. In fact, I have personally driven from Norfolk to Virginia Beach, and I observed snow changing over to a cold rain in just a 15-mile distance in the winter season. Just phenomenal. Now, some of the most dynamic snowstorms, additionally, they have produced these mesoscale or smaller scale convective bands with snow rates up to 3 inches per hour. Now, these bands form over more smaller scale or shorter horizontal distances, resulting in a drastic snowfall gradient or major differences over short distance of how much snow actually accumulates. You could have a location, for example, closer to the coast at about 12 inches of snow in some of the heavier, more dynamic snowstorms, but maybe you drive 25 to 30 miles to the northwest, and those 12 inches that occurred along the coast might drop all the way down to like 4 to 5 inches. So you can get really drastic changes in snowfall rates and snowfall accumulations based on some of these more dynamic snowstorm setups. Also, I have personally observed a lot of times most of these winter storms are going to start off as just a plain cold rain, transitioning over to snow as you get colder air aloft working into the area. If you have the high pressure, the Canadian high pressure situated to the north-northwest, you can get a nice cold northerly wind flow, and that's going to result in the continued cooling of the air column, and that will a lot of times change things over from a cold rain over to a snow. It's very rare in Hampton Roads, Virginia cities, to just get a winter storm that just starts off as snow and that's it. A lot of times what happens is a cold rain changing over to snow, okay? And underneath, as that snow accumulates, specifically overnight after sunset, what you'll do is you'll end up getting a layer of ice beneath the snow. Some of the biggest coastal snowstorms have resulted in the coast, again, getting more significant snowfall accumulations. While areas such as Richmond, 100 miles to the northwest, get next to nothing because they're on that backside of the storm system. You have high pressure in the northwest, and you've got colder, drier air filtering into the Richmond area. But closer to the coast, you're closer to the low pressure system, the storm track itself. And so you're getting a lot more upward vertical motion near the coast. But then you've got high pressure and the cold, northerly, drier winds working their way into Richmond. And I've seen this so many times across southeastern Virginia. This sets up that very significant snowfall gradient from, let's say, Hampton Roads cities, Virginia Beach, and Norfolk, and then back to Richmond. In fact, a common situation is, and I've observed this on multiple storm systems, when the coast gets buried with a lot of snowfall, Richmond gets next to nothing. Now, when Richmond gets buried with a lot of snowfall, typically what you have on the coast is just a cold, nasty rain. Just a cold rain, temperatures about 40 degrees Fahrenheit. Richmond, meanwhile, is just cashing in and getting a lot of heavy snow. So real interesting stuff, the way these storm dynamics can work. The common theme that we always look for Hampton Roads, Virginia snowstorms is for cold air to proceed, basically be in place 2 days to 3 days before any kind of overrunning moisture comes up from the southwest. So usually we have a cold high pressure system situated to the northwest that advects or transports colder air into the area from the north with below normal temperatures, usually 48 to 72 hours prior to big time snow events. That colder air is going to also, in addition to keep the temperatures of the atmosphere much colder, it's going to also allow for colder ground, thereby limiting the amount of melting of the snow once it starts to fall. Now, I've seen modeling output for this area in the Hampton Roads cities, where it might say, hey, Hampton Roads cities are going to get 8 to 12 inches of snow. But if we don't have that cold air in place preceding the storm, what's going to happen, or even if we have rain falling preceding the storm, what's going to happen is you're going to have a lot of the initial burst of snow fall and just melt upon impact with the ground. And I've seen, a later winter type system, which model outputs were just crazy, absurd numbers, 12 to 16 inches of snow for Hampton Roads cities. And Honestly, I'll just say from observation, it must have snowed about 6 to 8 hours, and all it did the whole entire time was melt upon hitting the ground. So again, I cannot emphasize enough the importance of having a colder air mass well below normal temperatures in place, high pressure to the north, cold high pressure to the north and northwest of the area. You really need that to really cash in on significant snowstorm accumulation events. Some of the biggest coastal snowstorms have resulted in the coast, again, getting those very significant snowfall accumulations, and this is kind of like the point I've already made, areas further back to the northwest. And we're talking 100-mile difference in the distance between, say, Virginia Beach and Richmond. And you can get this huge amounts of snow across Virginia Beach, and then Richmond has next to nothing due to colder, drier air working in on the storm's backside. I've also driven from the Wakefield area in Virginia along Route 460, driven from there to Virginia Beach, and in Wakefield, there's like no snow on the ground. And then I remember coming back one time from a trip, I got to the Hampton Roads cities, and it was just like, whoa, where did all this snow come from? I'm talking 10 to 11 inches of accumulation. In one event I personally observed, there was nothing on the ground back at Wakefield, okay? And by the time I got here into the Hampton Roads cities, it was like a complete blanket of white everywhere. So really interesting stuff. Again, we want the common theme for cold air to be in place, overrunning moisture coming in from the south and southwest, get a nice coastal storm off the southeast coast, and that's going to be very important. Water temperatures is another very important thing that we must discuss when we talk about Hampton Roads snowstorms. These water temperatures are critical. There's a lot of bodies of water in the area here. And whenever you have a body of water that's unfrozen, okay, you are going to have some sort of modifying influence on the overlying air mass above that unfrozen body of water. And we happen to have one really big body of water in the Atlantic Ocean right offshore. So the water temperatures are going to be extremely critical, how cold they are in determining a rain versus snow situation. Now I'm going to get more specific into the criteria here in a minute and kind of go over those water temperature breakdowns. The surface wind, another critical component to getting snow in the Hampton Roads cities. It really must be primarily from the north. Northeast winds off the Atlantic Ocean, off that water, tend to modify the colder air mass just enough in many cases to produce an elevated warm layer, that area above 32 degrees Fahrenheit aloft, and snowflakes will start off in the upper areas of the atmosphere, and as that snowflake falls towards the ground, it melts to rain as it reaches the surface. So we got to have the right wind component. We got to have the really good water temperatures, the colder water temps. In a lot of cases, what you see with cold frontal passages in the winter season is the common theme, and it's so frustrating for snow lovers, okay, you'll get moisture and plenty of precipitation, but with that moisture comes warmer temperatures. In some cases, it's just warm enough to be liquid. And then the cold front will go through, and then the winds will shift around to the northwest, and when those winds go northwest, the game's over. It's over because the northwest winds are going to advect or transport drier air into the atmospheric column, and it's going to shut off that precip, that moisture supply immediately. And so a lot of cases, it's very rare to get any kind of snow systems, I will say, from frontal passages. I've only actually, since 2019, observed this occurring one time, and it was a system with really good upper level dynamics, very strong cold front, and also it was more of an anafrontal type of front where you have rising air motion back behind the actual front itself, back into the cold air. And so we had a changeover from rain to snow. But that is the only time, I've observed this in over 11 years, is with frontal passages. You just don't get that changeover from rain to snow very often. You'll get the moisture, but it'll be in the milder air ahead of the front. And then cold, dry air will follow the cold frontal passage, and you won't get any moisture remaining. It'll just dry out as high pressure builds in from the northwest. Okay, so now let's take a look at the winter weather criteria. This is very, very important for the Hampton Road cities. This is really what criteria we need to take a look at. All right, so first bullet here. At 36.5 degrees Fahrenheit, rain and snow can occur with equal probability. So an air temperature at 36.5, you have an equal probability to get rain or snow. Most likely in this case, at that temperature, you're going to get a rain-snow mix in Hampton Road cities. If you drop that air temperature to 34 degrees Fahrenheit, the probability of snow goes up to 95%. So that is, just 2.5 degree difference, right? And these air temps can mean all the difference in the world between a rain-snow mix and just straight up snow. Snow will rarely occur with air temperatures above 40 degrees Fahrenheit. Now, if I were to go up in the atmosphere and look at an 850 millibar level weather chart, 850 millibars being 2,500 feet generally above the surface, I'm sorry, not 2,500, that's 925 millibars. 850 millibars is about 5,000 feet above the surface. And at 5,000 feet above the surface, the critical temperature you're looking for at that level is a negative 3 degrees Celsius or colder temperature for snow to occur. So you want at 850 millibars, 5,000 feet above the ground, the air temperature about negative 3 degrees Celsius or colder. When I say colder, it could be negative 4 Celsius, negative 5 Celsius, and so on. If I look at just a 1,000 to 500 millibar thickness chart, okay, here are some of the key thickness parameters, okay? So 537 decameter thickness or less is generally going to be all snow. Now, you remember what I said here, right? Now look at this. Normally, if you're at the 540 decameter line, the thickness line, east of the Mississippi River across eastern U.S., okay, normally if you're less than 540 decameters, you're snow in the east. If you're greater than 540 decameters, you're rain. So this 540 decameter thickness line is generally used for that rain-snow line east of the Mississippi River. But because the Hampton Roads cities are near the Atlantic Ocean, where we have modifying influences of the water, you need thickness levels lower than 540. You need it to be 537 decameter thickness or lower to get snow here. 537 to 541 decameter thickness is going to generally result in a mixed rain and snow event. And then if you get to 541 decameter thickness or greater, it's just going to be a cold rain. Okay? So these thickness values are also important. I would say just consider this the winter weather checklist or winter weather criteria that meteorologists look at to determine is it going to be a rain or snow event. This is one of the most tricky, most difficult areas to really forecast for winter precip events. And the differences between snow and rain may only be like 25 miles. So it's very difficult, but some of these are some of the rules of thumb that are looked at. Now, if we look at the freezing level, that freezing level is going to be the height above the surface at which the temperature is 32 degrees Fahrenheit at the freezing point, okay? Anything above the freezing level in the atmosphere is going to be below that 32 degree Fahrenheit value. And so using the freezing level, it's got to be 1,200 feet above the ground to ensure most of the snow will melt before reaching the ground. So if your freezing level on the freezing level charts is 1,200 feet or higher in height, okay, 1,200 feet or higher, then so it could be 1,300 feet, 1,500 feet. Most of the snow is going to melt before reaching the ground and just become rain. Now, if we have a freezing level of 1,200 feet, if it's at 1,200 feet alone, the freezing level, that is, it provides an equal chance of rain and snow mix. Freezing level of 800 feet. Now, so you notice how we're lowering the freezing level where that 32 degree Fahrenheit temperature is? The closer this freezing level is to the ground, the greater the probability for snow. In fact, freezing level of 800 feet and lower, so between 800 feet above the ground to the ground, basically, in that area, you're increasing your snow probability to 95%. We're talking feet here. Not very drastic feet, just slight little tweaks. And again, that's what makes winter forecasting so difficult here in Hampton Roads cities. Now, over 80% of all frozen and freezing precip has occurred with a wind direction from the northwest to northeast. Now, I will say this. You don't want it strictly northwest because it's going to be bringing that drier air in. Okay. I think the sweet spot is generally between 340 degrees and 360 degrees. So northwest to northwest, I think, is the sweet spot for real good, significant snowstorms in Hampton Road cities. This northeast, I grew up in the Midwest. When we had a northeast wind in the Midwest, it was game on. We were going to be on the cold side of the cyclone. We had the moist conveyor belt wrapping into the system. And I knew when the winds were going northeast of the Midwest, we were going to get hammered. We were going to get hit hard with a significant snowstorm. But not here in Hampton Roads because, again, the influence of the Atlantic Ocean waters. Now, snow accumulation is associated generally with cold surface winds. Here's another case where you can get some snow showers. Now, these usually don't accumulate. Okay. Everything I've talked to up to this point is generally be associated with a coastal low pressure system. But you can also get snow in the air, basically to fall, these snow showers, with cold surface winds if they're set up in the right directions, pretty much from the north. Cold northerly winds are going to run over the warmer waters of the Chesapeake Bay, the relatively warmer waters of the Chesapeake Bay. So you get these cold surface winds blowing over a warm, moist surface is going to pick up moisture from the Chesapeake Bay. Specifically, if you get a longer trajectory of those cold northerly winds, that colder air over the Chesapeake Bay, even over the Atlantic Ocean it can occur, but it's not as likely. But you can get these effects called bay streamers, to where you get cold, dry air moving over a warmer, moist water surface. It picks up the heat and moisture from below, similar to the Great Lakes. Down in the Great Lakes, you may have heard of lake effect snow. But it is a very smaller scale, mesoscale type process for the Hampton Road cities. I have seen snow fall due to this, but usually these aren't the big snowfall accumulations or the big snowstorms. Now, I told you about the water criteria. When the local water has a temperature above 40 degrees Fahrenheit, an active exchange of moisture from the water right to the lower layers of the atmosphere is occurring. So you get a lot of mixing between the above 40 degree water and then the lower layers of the atmosphere. So a lot of vertical exchanges of heat from the water below, and that's going to limit your possibility of getting snow. Now, when the local water has a temperature below 40 degrees Fahrenheit, on the other hand, the vertical mixing of the water occurs as it attempts to reach this equilibrium, limiting the moisture exchange, and the probability of snow increases. So air temperatures below 40, probability of snow increases. But more importantly, here's a good breakdown of the sea surface temperatures for rain versus snow. So 41 degrees Fahrenheit water temperatures are rain. You get a water temperatures in 38 to 41 degrees Fahrenheit, we got mixed rain snow possibility. And then if the water temperatures are 38 degrees or less, you get snow. Now, this is why it's so important that the winters aren't too mild. This is why you need, especially the early portion of the winter kind of sets the stage for later winter. You want colder air masses continuously coming down from Canada. That overlying colder air really going to work its way down towards the surface, towards the water surface, and these water temperatures are really going to get colder. All right, so here are some of the winter storm tracks. Winter storm tracks are very essential for Hampton Road cities to determine rain versus snow. The first one here on the left is an inland track. You see that red L, low pressure system. It generally skirts right inland along the coast across northeast North Carolina into southeastern Virginia. And this type of track here on the far left is associated with rain, potentially severe thunderstorms if you get a nice little low-level jet stream here kicking in at 5,000 feet above the ground. And you get a lot of turning of the winds with height, some of that directional shear can result in severe thunderstorms for southeast Virginia. If you get more of a slightly offshore track, 50 to 100 miles offshore, now you're kind of bringing that colder air closer to the coast. It's not quite here to the Hampton Roads area, but this purple area indicates snow. The green is rain. So you kind of see where the rain-snow line is now. It's much closer to the Hampton Roads cities with a slightly offshore storm track, 50 to 100 miles offshore. Now what happens if we get this type of storm track on the far right, where you get farther offshore track, Cold air is pulled all the way to the coastline here, with precip shield mainly east of I-95. Coastal regions get significant snowfall in this aqua color here across northeast North Carolina and southeastern Virginia, including Hampton Roads cities. So the track of the system, very, very important, okay? It can't be too close to the coast because you're going to get an onshore wind component that's going to modify the overlying air mass, and you're going to be probably in a cold rain situation in Hampton Roads. If you go a little further offshore, you got a little bit more colder air closer to the coast, and the rain-snow line also shifts closer to the coast. And then the further offshore track, and I would say here distance-wise, we're talking about 150 miles probably, about 50 further miles east. That's why you see the TV meteorologist in the local Hampton Road cities always showing the storm track and the various modeling, GFS versus European storm tracks, and why it's so very important. If we look at smaller scale or mesoscale effects of some of these winter storms for southeastern Virginia, I know I'm not showing southeastern Virginia here. I'm showing Jersey, Long Island, into Connecticut, Rhode Island, and Massachusetts. But this also happens into the mid-Atlantic, including coastal Virginia and the Hampton Road cities, where you get upper-level features that basically align themselves to become favorable for some additional vertical lifting, enhanced vertical lifting, resulting in intense precipitation bands showing up. And this occurs where you get these bright yellows, higher reflectivities on the radar here. You see the scale here on the right. When you see the yellow banding, the orange coloring, these bands, that's associated with very intense, heavy snow rates, heavy snow pockets, I like to call it, which can result in significant snowfall accumulations, very large differences over shorter distances in the horizontal. Some of the biggest, most dynamic snowstorms for Hampton Road cities have produced these types of banding features. In fact, conditions can be so unstable with what's known as slantwise convection in the winter with these kind of dynamic systems in which you can actually get thunder snow with this type of event. Now, I wanted to show you the seasonal snowfall for Norfolk, Virginia. Okay, so this goes from 1890-91 winter season to the 2017-2018 winter season. So I didn't quite go all the way out to 23, to our current time period, but it gives you a good idea of how the trends have changed over the decades here. You kind of see some of the big snowier winters here, the late 1930s. We see another major spike here in 1980. That was a big year for the area. Additional higher amount seasons was in the 89 winter. The February 89 specifically was a very snowy month for Hampton Roads cities, February 89. And then you see additional higher points here of snowfall, higher seasonal totals. 2009, 2010 is another one, or 2010, 2011 rather. That was another big type of season, okay? We also got decent amounts of snow in that 2017-18 winter. One thing I want you to realize about seasonal snowfall, it can appear that, you know, as far as the amounts go, it sometimes is only just one major snowstorm that can really elevate these amounts, right? So, for example, in January 2018, I'm going to talk about that storm, you know, we got a good 10 to 11 inches of snow in just one snowstorm in early January 2018. So that's like over 50% of this total for the season, right? Again, 2010, 2011 winter, that December 2010, late December 2010 storm produced up to 13 to 14 inches of snow in Hampton Road cities. And, you know, that's over half, probably up, let's see, that's about 60% of the seasonal snowfall total. So just because you see higher seasonal snowfall totals doesn't mean it's like continuously snowy all winter. There could be just significant snowstorms in that data set. Let's take a look at the seasonal snowfall now by decade breakdown. And we're going all the way back to 1890s for Norfolk, Virginia. And let's see, some of the most snowiest winters or decades was the 1930s. Now these were seasonal snowfall averages by decade. This wasn't the snowfall total by decade. These were averages. So Hampton Road cities averaged a foot of snow each winter in the 1930s over that decade. We also averaged about 10 inches over the 1960s each season, and then it went up to 10.9 inches. A lot of that factored into the late 1970s winters. And then the 2010s, you know, it came back up again from the 2000s. Where we got, you know, an average of 9.1 inches each winter season, okay? some of the least snowy averages per season, whereas the 2001 to 2000, would this go to 2009, only averaging 4 inches of snow for the season. That's one of the lowest points. So bottom line is there's a lot of variability and ups and downs per the decades, isn't there? Now let's take a look at some of the memorable Hampton Roads snowstorms. We'll start this one off with the Circus Blizzard of March 1980. Now this was the biggest snowstorm in nearly a century. I believe this is the biggest snowstorm, I believe, since 1892. We'll take a look at that data here in a moment. But why they call this a circus blizzard is because many folks were attending a circus that was in town inside the Scope Arena. And as they were sitting in there watching the circus, the weather conditions rapidly deteriorated outside. Roadways became nearly impassable, had a lot of wind with this particular system, so a lot of blowing snow. 13.7 inches of snow was recorded in Norfolk with the circus blizzard. And what's the irony of all this is it was so late in the season. I mean, it was early March of 1980. This capped off, by the way, the winter of 79-80. This capped off one of the biggest snow seasons for the Hampton Roads cities, specifically in this case in Norfolk. It was a very big snowy season in the 79-80 season. Here are some of the charts now that kind of show the setup. This is one of the common themes you're going to find is a very strong high pressure system starting to build in and work its way southeastward from central Canada. So we have this colder air, clockwise flow around this massive high pressure system from Canada, getting strong northerly winds, advecting or transporting much colder air into the mid-Atlantic and the eastern U.S. from eastern Canada. And then what you get to develop along this front here to the south is you get a wave of low pressure or storm system to develop. At the 500 millibar level here on the right, this chart back on March 1st, 1980, we have a positively tilted upper level trough here across the Midwest. We have some of the diffluence out ahead of the trough axis. So we have the spreading apart of these height contours resulting in some upper level divergence, removal of mass aloft. That's going to increase your low level convergence or rising air motion, and you're going to get a storm system develop. Additionally, one of the key features for the mid-Atlantic really to get a nice little snowstorm is what's known as a 50-50 low up here. There and around just off the coast of the Canadian Maritimes, the Southeast Maritimes of Canada. Now, as we move forward in time, I always like these older NOAA charts, what was going on. This is the surface analysis on the left. But I really like the comments the forecasters made, whoever was working that shift. You can see at the one here on the left here, surface chart analysis, they put 6 to 10 inches of snow across western Virginia and Virginia next 12 to 18 hours. So they were already forecasting a major storm to develop, major snow to accumulate in the mid-Atlantic at this point in time on Saturday, March 1st, 1980. And so all this gray shaded area indicates falling precipitation, by the way. You kind of see there was a stationary front here draped across the northern Gulf of Mexico on the morning of March 1st, 1980. Meantime, by March 2nd here on the right, the 500 millibar chart, we're seeing a closed upper level low pressure system now over western Tennessee. And out ahead of this trough axis, we got a neutral trough axis, a neutral tilt. We're getting a lot of diffluence, or we're getting a lot of upward vertical motion, rising air motion, generally in this area right here ahead of that closed upper level low. By the time we get to the surface chart for March 2nd, Sunday, March 2nd, 1980, look at the gray area here. A lot of this up here into Virginia and parts of northeast North Carolina was all snow up here, and it was coming down hard. Here is another note from the forecaster. They put on this particular image, later this day on Sunday, March 2nd, 1980, worst blizzard on record hit eastern North Carolina and southeastern Virginia. Basically coldest weather entire winter in the mid-Atlantic states. So you can see a high pressure system situated over the Red River here that borders Oklahoma and northeast Texas. And we're talking 1038.5 millibar high pressure system here at this plot or station in northeastern Texas. So Extremely cold air goes all the way down the Gulf Coast, down the Gulf of Mexico. You get strong northerly winds. You got all the ingredients in place. You got the colder air in place. You got a look at the storm track here. Where is it located? I'm gonna draw you. I'm gonna hang on here. This is where this low pressure was located. This was the storm track here. So you see how it's a more offshore type low pressure or storm track there. So this area remained in the cold air the whole entire time of that storm track. Here's some of the pictures that occurred. This one here on the left is courtesy of the Virginia Pilot, the local newspaper, and it always makes me laugh. You see these young people trying to push this person out of this major snow area. What really makes me laugh is the dog, the dog here, how he's like just kind of up on his back two legs, and it almost looks like he's helping the kids push whoever this is in this car stuck. Pretty funny. Now, here is why they call it the circus blizzard. I mean, look at this. They're transporting the elephants after the storm is over. Look at the crystal clear blue sky here across Hampton Roads cities. Specifically, this is the Norfolk area. They're literally taking these elephants out of the scope arena and like getting them loaded up into the vehicles to go to the next city. And they're just walking on the snow here. This was all the snow accumulation left over after the storm. This is why it's called the circus blizzard here. Let's move on now to another fairly significant snowstorm for Hampton Roads cities. This occurred on 17 and 18 February 1989. So what kind of set the scene for this particular event? Temperatures had actually dropped to record lows for 35 cities over the period. Generally from the Great Lakes all the way southward to the Gulf of Mexico, Arctic air just surged south. In fact, Miami, Florida had posted a record low down to 37 degrees in Miami. That equaled the temperature in Minot, North Dakota. So imagine you're sitting in Miami, going down on vacation, getting away from old man winter down there, and your temperature is 37 degrees one morning in February 1989, and it actually equals the same temperature they're getting in Minot, North Dakota. Just crazy, right? Now, this particular snowstorm actually closed schools from Georgia all the way to New Jersey. The storm dumped over 12 inches of snow across southeastern Virginia, with wind gusts, now this is incredible, up to 60 miles per hour. Some of the most intense winter storms produce very strong winds. Now, this was the first blizzard, by the way, for Hampton Roads cities in 1989 since the circus blizzard occurred 9 years earlier in 1980. This storm, by the way, capped the snowiest month on record in Hampton Roads, February 89. What happened synoptically, we had low pressure that formed off the coast of the Carolinas. There's actually blizzard conditions reported along the Outer Banks, believe it or not, where 18 inches of snow fell and they had up to 3-foot drifts. Now remember, you get the snow on the ground, right? But then you whip it up in 60 mile per hour wind gusts and you can get up to 3-foot drifts in this case. 3 feet high, amazing. Now temperatures had fallen into the teens across parts of Mississippi, Alabama, and Georgia just a week after they experienced record highs in the 70s and 80s. So there was a major deep trough that set up in the eastern U.S. Extremely cold air got pulled down all the way down to the deep south. We had record lows, 16 degrees at Birmingham, Alabama, 19 degrees in Mobile, Alabama, all the way down the Gulf Coast, 23 degrees in Baton Rouge, Louisiana, 28 degrees at New Orleans, and 17 degrees all the way down to Atlanta, which tied their record. This is that preceding cold air mass that I was talking about that really is a necessity for Hampton Roads snowstorms. General coastal mid-Atlantic snowstorms. Here's some of the charts. This is the surface chart here on the left. This was Saturday, 18 February 1989. We had a nice wave here. Let me go get my pen out here again. We had a nice little area of low pressure here off the southeast coast. We had that high I'm always talking about right here, that strong cold high to the north. And that's going to advect or bring down colder air to coastal Virginia, southeastern Virginia here in the Hampton Roads area. So all this precip, this gray shading is going to show up and it's going to be snowfall. Over here on the right, we see the 500 millibar chart generally showing up. Let me see if I can find my pen again here. I lost it. Okay. Anyway, let me see here. Yeah. Okay, I got it back. Sometimes it gets tricky to find these things. Anyway, we got, this is February 18th, 500 millibar chart. So we have a little bit of a ridge that's kind of building up out here in the western U.S. We have troughing that's developing now into right here. So out ahead of the trough axis, you're going to get rising air motion in this general area here. All right, so that was kind of a breakdown of that particular storm and some of the old weather charts. Let's now fast forward to this one. This was a mammoth one. I missed this one, and let me tell you something. I'm bummed about missing this one. I was back in the Midwest. Don't get me wrong. I was enjoying myself. I had 3 different snow systems come through the Midwest where I was at. I was loving life. Anyway, this storm, 25 to 27 December 2010. What happened was there was a strong area of low pressure which produced significant snowfall across much of the southeastern U.S. and East Coast. Snow actually intensified across coastal regions of the Mid-Atlantic on the 26th of December. This includes Hampton Roads cities, by the way. Major metropolitan areas impacted: Raleigh in North Carolina, Norfolk in Virginia, and then that storm just bombed out as it continued to move off the Mid-Atlantic coast up towards New England. Philly, you got a lot of snow out of this. New York City, you got a lot of snow out of this, as well as Boston. By the way, this particular snowstorm ranked as the 3rd snowiest event all time for Norfolk, Virginia, and then Newark as well, and then the 6th snowiest event for New York City's Central Park. Northern New Jersey, as that system continued to intensify as it moved northeast right off the coast, northern New Jersey at Rahway received 32 inches of snow. I mean, can you imagine seeing that outside your window and your doors? So what happened was there was a strong upper level ridge in place that began to build over the western U.S. in response to an approaching trough coming in from the Pacific Ocean. You had these little shortwave disturbances or these troughs embedded in the northern wind flow there associated with the polar front jet. And then you had a shortwave trough in the southern stream or the subtropical jet. They began to dive, these disturbances or troughs began to dive down the backside of the strengthening ridge, moving into the northern plains by Christmas Eve. Now, the southern stream shortwave, that little disturbance in that subtropical jet area, it moved eastward while the northern stream shortwave trough, the one disturbance with the polar front jet, was diving southward. And they basically it was diving towards the southern stream disturbance, and they merged and formed one massive storm. So at the surface, you get low pressure that formed, moved eastward. You get that cold high again to the north of the system as the northern stream trough moves southward. And then by early Christmas morning, we've got the polar front jet taking a nosedive deep into the deep south. We have 5,000 foot temperatures reaching freezing 32 degrees Fahrenheit as far south as northern Louisiana and central Mississippi. And then further aiding in this storm's development were other dynamics in place. We had the jet stream. We had an accelerated region of winds within the jet stream core, and that's known as a jet streak. We also had enhanced rising air motion or vertical air motion, producing significant amounts of snow, even over northern Alabama, Mississippi, and Georgia, as well as portions of Tennessee and North Carolina. What happened is, again, the merging of those 2 disturbances, those 2 shortwave troughs, one from the polar front jet, one from the subtropical jet, they merged on the 26th, forming just one massively amplified trough over the eastern U.S. And as this occurred, the surface low pressure system really began to deepen or intensify significantly and move up northeast along the Atlantic coastline, get the colder air, lower thickness values behind the strengthening cyclone, and it was a game on here at this point. So bottom line here, a lot of dynamics involved. I'm going to continue to move on. I won't really delve too deep into that. That's not the point of this. And by the way, I've already explained kind of this dynamical point, these points from the dynamic standpoint in my previous video, the memorable East Coast winter storm. So feel free to go back and take a look at that video for further explanation. But bottom line, when you get this upper level divergence or spreading apart, removal of mass over the top of any kind of low pressure system, it's going to increase your low level flow or converging air at the low levels on the ground. And whenever the air converges in the low levels, it has to go up. It rises, and you get much more intense precipitation rates, which happened for places like Norfolk, Virginia. All right. Additionally, we had those mesoscale convective bands setting up, producing very significant snowfall. So you're getting a lot of strong easterly winds coming in, bringing that moisture in from the Atlantic, strong northerly winds in the backside of this intensifying cyclone or storm, That's bringing cold air southward. And the points where those two streams of air meet, the easterly winds and the northerly winds, that's going to result in increased low-level convergence of rising air motion, a very large temperature gradient. That's the energy for the storm. And you're going to get these intense, smaller scale or mesoscale convective snow bands. Here were the charts, what was going on here at the surface on Christmas of 2010. We have the area of low pressure developing in the Gulf of Mexico. Let me go ahead and oops, let me do this here. So we have this area of low pressure developing here in the northeastern Gulf of Mexico. And look at this, folks. We got the high pressure system to the northwest, right here. And it's a strong one, 1036, in excess of 1036 millibars, okay? So a very strong cold high pressure system, cold air funneling in. We've got some warmer air, or not really warmer air, but moisture overrunning the cold air at the surface here from the southwest. And look at your heights here. You have a major upper level ridge here, positive PNA, upstream, and then downstream from that, you got a deep trough that is just, there's a lot of cold air here available, okay? You get these little short waves that are in this flow here of the polar front jet, and then you get, like a subtropical jet coming across at the same time. And then when these two areas here meet and merge right off the coast, you get one huge low pressure system here that's going to just ride up the coast. Right. 26 December, we really have a situation developed. We have a very intense low pressure system right off the Carolina coastline. By the way, this blue dashed line is your 32-degree Fahrenheit line at the surface. Anywhere north of this 32-degree line, this blue dashed line, is all snow here, okay? And now we have a very intense system. One of the signs of a very intense system is a closed upper level low position over eastern Tennessee. And it's game on here. You got a very strong, moist feed of air coming in from the south there at 18,000 feet, overrunning the colder air at the surface, and you got a heavy snow event. By the 27th of December, this thing's bombed out, and it's situated now, the intense storm, right off of Cape Cod. Damage has been done all the way up and down the coastline here, okay? You got an intense closed upper level low now, which has moved northeast to almost vertically stacked on top of the surface low here, which is sub 976 millibar central pressure, just impressive. Whenever the upper level closed low here vertically stacks over this surface low, that's usually when the storm begins to dissipate or weaken. Here are some of the snow totals. This was a beauty of a storm if you like snowfall along the coast. Hampton Roads cities cashed in here. It says 10 to 20 inches here, but it was around 13 to 14 inches along the coast. And then as the storm moved off the coast here, I'm telling you, this thing kept getting stronger and stronger as it moved up the coast. And so you see a wide swath of just massive snow amounts from Jersey, Long Island, Connecticut, right up to Massachusetts. Here's the snowfall total for Norfolk, 14.2 inches. By the way, this was the third most all-time for one particular winter storm for the Norfolk area. And then this satellite image pretty much tells us everything we need to know. We got a nice, intense, deeply occluded low pressure system here off of Cape Cod. The speckled nature to these clouds here on the weather satellite imagery, that indicates very cold air coming in off the east coast. Behind the cyclone, you got strong northwesterly winds. And as those cold, dry northwesterly winds move over the warmer Gulf Stream here, it creates these unstable looking clouds here, these speckled clouds, these open cell cumulus clouds. Now let's move on to one more storm I want to cover for you. This one occurred on the 4th of January 2018. I remember this one well, and I was so fired up about it. We had one of the checklists, right? We had the cold air preceding the storm. That's good. By the way, the high temperature was 26 degrees on the 1st of January here in Virginia Beach. Okay, 26 degrees on the 1st of January. That's 20 degrees below normal. This caused the ground temperature to be quite cold, allowed for more immediate snowfall accumulations. Okay, so we got a preceding cold air mass. We got 20 degree below normal high temperatures at 26 degrees preceding the storm. In fact, I remember up at Times Square for New Year's Eve on 2017. It was one of the coldest New Year's Eve up in Times Square. It was 9 degrees above zero air temperature in New York City. That, my friend, you know that if any kind of storm system were developed or any moisture overrun, that kind of cold air, you're in business for some snow. Now, the cold air, additionally to preceding the storm, it also lasted well after the storm, which was really rare for Hampton Road cities. Usually we get hammered with a good snowstorm, and within 2 days, the sun's starting to melt all the snow, the temperature's warm above freezing, and then a few days later, the roads start getting more wet instead of white. But in this case, after the snowstorm in 2018, just impressive, okay? The high temperatures remained in the 20s with overnight lows in the lower teens for multiple days after this big snow event. This did not allow for melting of snow. In fact, there were many people that were still not going to work 3 days after the event just by the simple fact of how much snow fell with the storm, but also that these air temperatures remained so cold. And there's really no snow plow or snow removal equipment down in the Hampton Roads, Virginia cities. The storm deepened by 53 millibars. I mean, look at this, guys. 53 millibar drop in central pressure in just 21 hours. All right, a meteorological bomb is a 24 millibar drop in 24 hours. So just extremely impressive the way this thing intensified. We had a snowfall total just over 10 inches here in Virginia Beach. I personally went out with the yardstick in the yard, and I was like, wow, this is deep. The winds gust up to 69 miles per hour in Hampton Roads. We had blizzard-like conditions, no doubt about it. This was the surface weather chart for the 3rd of January, so this is the day before the event really got going. This is where the wave of low pressure is developing here over just east of Jacksonville here. So you have a stationary boundary here, a wave of low pressure forming along the boundary. You got colder air in place here to the north, preceding the moisture overrunning that cold air from the southwest. And look at the trough, guys. Look at this trough. Beautiful. Deep trough, more neutral tilt coming in from the Midwest. A lot of upward vertical motion is going to be favored ahead of the trough axis along the southeastern and mid-Atlantic coasts. And then look at this, positive P&A. You've got ridging out here in the western Pacific Northwest up to Western Canada. Just a beautiful setup. Now, by the time we get to the 4th of January, we got a monster on our hands here. An absolute beast of a storm. The pressure here is just phenomenal. I mean, these isobars, these solid lines are just so tightly wrapped. I mean, you're looking at, I think I see 964 here. So below 964 millibar central pressure. We got all the snow that's just going on here from southeast Virginia right up to New Jersey, Long Island, up to southeast Massachusetts. This thing's a beast. And then at the 500 millibar level, 18,000 feet, you still see that positive P&A here with the ridge axis extending all the way up to the Northwest Territories. And look at the depth of this trough here. Ooh, goodness. That's a deep trough, and it's slightly negative at this point. I know that's not where it's supposed to be. It's supposed to be right over here. But it was slightly negative, the trough axis at this point, just promoting just rapidly rising air motion. Here's the satellite image of this thing. I mean, this was off of the Virginia Capes at this point, 4 January 2018, 8:45 in the morning Eastern Time. Here's the center of low pressure right here. This thing's a monster. And, you got, look how the coverage area here you got of the cloud shield. I mean, this goes way up here. This is just impressive, the way this thing was structured. A lot of cold air is coming out over the Gulf Stream here. That's why you get the speckly nature of these clouds, indicating unstable conditions. Colder air, much colder air over a warmer surface. Yeah, this thing was just impressive. And this was the storm track over here on the right, kind of showing you. See where the center of the storm stayed? Well offshore. It wasn't too close to the coast. It remained far enough offshore to where the cold air remained in place in this area, and that was a sweet spot for snow. Here was some of the warnings that were occurring on. This was from January 2nd to the 5th in the eastern U.S. during the winter storm. All right, this thing dumped snow in Savannah, Georgia. It dumped snow in Charleston, South Carolina. Just impressive. So the red coloring is blizzard warning. We had a blizzard warning in Virginia Beach. You have blizzard warnings going up to southern Jersey, Delmarva. You have blizzard warnings up into southeast Mass, as well as southeastern down east Maine. Just an impressive storm system. This was some of the pictures. This is the picture that occurred in Hampton Roads during the height of the storm. It's coming down so hard on the interstate here, the snow. And this was the snow totals here on the bottom right from January 3rd to 5th, 2018. You see the orange coloring here. this is when things really got going for higher snowfall rates. And you look at where the yellow and oranges go, right along the coastal sections of the Mid-Atlantic, all the way up to Boston and all the way up to Maine. I mean, but this really, at the Virginia line northward, this is really when the system bombed out here and just produced just incredible amounts of snow. All right, that wraps up my video this evening. Hopefully it wasn't too lengthy. I get excited about this stuff. I'm not going to lie. If you live in the Hampton Roads cities, hopefully you enjoyed this presentation. I'm going to continue to work on future presentations here. I have been promising I need to get back into the teleconnections discussion, get another video out to everybody. Also, some of the long-range forecasting discussions. I need to get back into that game too here, get back into that mode and routine. But I hope you enjoyed this presentation for now. Keep following me. I have a Spot on Weather Weebly website, specific forecasts, 7-day outlooks for Hampton Road cities. And I also do a lot of other great things on the Spot on Weather. Search Spot on Weather Weebly, and you'll find my website. I also produce a weekly newsletter during this time of year, and it's absolutely free. I open everything up. I give you all this information, all the forecasting knowledge and expertise, absolutely free. Just sign up, go to the main homepage of Spot on Weather Weebly, get on there, get on our list, our subscriber list. We'll kick out all of our latest newsletters, our weekly newsletters to you right to your inbox, your email. And stay with us here at Spot on Weather as, you know, we're wrapping up. Heck, we're past Thanksgiving now. We're coming up on December quickly. So please feel free to follow us on Twitter, now known as X, as well as on Facebook, Spot on Weather. Search us for the latest information and data. And that's all I got for now, everybody. Until next time, everybody, take care and God bless.